Hey everybody, this week we're going to talk about probability within NLP and chatbots. We'll focus on Bayes theories and Bayes rule to kind of understand how chatbots are able to predict the next outcome in user information. So let's get started. So in this section, you'll be able to understand the role of probability within NLP and how it helps chatbots function. We'll take a look at different models to help us understand user prediction and intent and respond appropriately. Then we'll introduce Bayes' rule, an essential tool that allows chatbots to update the prediction dynamically as they gather more information. And as we focus more on Bayes' rule, it is a powerful method for updating probability as new information becomes available. Chatbots are often encounter ambiguity within user inputs. And maybe the input could be a question, a command, or even a greeting. Bayes' rule helps the chatbot refine its understanding by updating its prediction as it processes more information. For an example, if the chatbot initially thinks that the user is asking a question, but then receives additional input that it may suggest otherwise, Bayes' rule updating allows the bot to adjust its prediction and respond more accordingly. We'll go through some examples of Bayes' rule. We'll have some practice problems that we'll work on, and we'll understand how it actually helps chatbot makes decisions over time. Next, when we think of probability within NLP, right, when we think of probability in general, we think about what is the measurement of a likelihood of an event happening, right? This is probability. So then we actually look at within NLP, how does the model understand what's to come, right? If you ask a question versus a command versus other things, right? How does the model understand that, right? So it goes through this entire process using Bayes' rule to kind of help understand different methods and kind of change a little bit, right? It all depends on intent. It all depends on the context of the message happening within the chatbot, right? So when we think of some examples, it's predicting sentences, if it's a question, command, or a greeting. So remember that it's super important depending on how the models are structured, is how the model will respond. So then we think about types of probability models within NLP, right? So first, we'll look at some different models. The most simplest is a unigram model, which calculates the probability of each of the individual words appearing in a sentence. However, this model isn't as effective because it doesn't take into account the context surrounding the word. A more advanced approach is the Bigram or even Trigram. These models calculate the probability of a sentence of 2 or 3 words appearing next to each other. So for an example, in the phrase, "what's the weather?" a Bigram model would be able to evaluate the likelihood of the word weather following the word the. This is crucial for capturing context and generating a more accurate response and prediction about the user's intent. The more words we include in the model, the more sophisticated it will be. The more context the model uses to predict what the user is asking, the more effective it will be. This is essentially useful within chatbots, as we know, where context plays a huge role in understanding what the user intent is. So now we get into what is Bayes' rule, right? So Bayes' rule is a statistical model for calculating the probability of an event based on the prior knowledge and the new evidence. It allows us to update our beliefs about something as we gather more information. So this is what the formula looks like. So the probability of A and B is the posterior probability. The probability of an event A, for an example, the user asking a question, given that the event B, the input, has occurred. And then we think about probability B and A is the likelihood. So the probability of observing the input given that the user is asking the question. Then there's probability of A, which is the prior probability. So the bot initially assumes about the likelihood that the user is asking about. And then there's a probability of B, which is the event. This is considered as the evidence. So the overall probability of the overall probability of observing the input regardless of what the user intent may be. So this formula allows chatbots to really refine the predictions about the user's intent as they receive new information. So in practice, Bayes' rule helps chatbot makes better decisions by updating probability as new input is received. Let's say that the chatbot starts with the posterior probability that the user is asking for information. Maybe the user often asks a question, so the chatbot assumes or assigns a probability of 0.6 as its intent. Then the bot evaluates the likelihood of the current input, such as how can I reset my password? If the input fits within the information seeking category, the chatbot may assign a likelihood of a 0.9 to this scenario. Finally, Bayes' rule calculates the posterior probability, which is the updated estimate of the user's input. In this case, the bot might increase the probability or the information seeking to about 0.85. This process ensures that the bot becomes more accurate as processing new information. So next, let's go into an example, right? So let's walk through this example itself. So imagine a user types the question, how can I reset my password? The chatbot begins with the prior probability of a 0.6, that the user's intent is asking for information seeking. Next, the bot assigns a likelihood observation to this particular input. If the user intent is asking for information, since reset my password is a common information request, the bot might assign a likelihood of a 0.9, 90%. Applying Bayes rules to the chatbot calculation, applying Bayes' rule, the chatbot calculates the posterior probability, updating the likelihood that the user is asking for information to 0.8. This process helps refine the prediction in real time, making the response more relevant and accurate. So now what I want you to do is take a moment and think about an example here. Well, let's go through this exercise. So let's put this on what we learned into practice, right? You've heard me talk about it, but actually let's go through this. So the first example, you'll calculate the posterior probability using Bayes' rule. Given that the prior probability is 0.7 and the likelihood of the observation is an input of 0.8, try applying the formula as we discussed earlier. Second, in the second exercise, reflect on how Bayes' rules updating helps improve chatbot's accuracy over time. Chatbot encounters a wide range of different inputs, and for each of this interaction helps the system learn and refine as it learns to understand its responses. And then think about how this process can lead to better user experience and more intelligent chatbots. Let's go over the exercise question. So the question is, calculate the posterior probability if the prior is 0.7 and the likelihood is 0.8. So make sure to use Bayes' rule to do this calculation. And it's pretty easy. It's just kind of like a plug and chug. We know a couple of the formulas. We know a couple of the elements within the formulas. So we know the likelihood and we know the prior probability. We just need to find the evidence. And the way to do that is that we have to structure it a little bit differently. So what we have to do is now we have to solve to find probability if for B. So what we got to do is take the probability BA, and then you're going to multiply it by the probability of A plus the probability of BA if A wasn't true times the probability of A if it's not true. So there's a lot going on here, so we'll go step by step. So what we already know is that the probability of BA is 0.8, which is the likelihood. And then we also know that the probability of A, or the prior probability, is 0.7. And then we have to add that to the probability of B with respect to A not being true, multiplying by the probability of A if it's not true, with the likelihood if it's not true. So what we'll get is, on the left-hand side, we'll get it to equal 0.56. Now, on the right-hand side, we have this issue of not understanding kind of what is being asked here. So with the probability of BA with A not being true, we are going to assume that it's 0.5, which is just a moderate likelihood that we have here. And what we also understand is that for the probability of A not being likely, we understand that we have to take what we already know, which is the prior probability of A being 0.7. So what we need to do is take 1 and subtract it by 0.7, because that is the prior probability. So what is the probability of it not happening? That will just be the subtraction of the probability itself. So that will equal us 0.3. So again, on the left-hand side, we have 0.56. Then we add that to, well, our assumption, which is 0.5, which is a moderate assumption. And now you're multiplying that by 0.3, which came from 1 subtracting 0.7. So then you add those together, and what you're going to get is 0.71. So this isn't your full answer. So this is just for the P over B, which is the evidence here. So take that back to the original formula, and now you have the probability of A over B equals 0.8 times 0.7. That's likelihood multiplying the probability, the prior probability, which we were already given. And then you divide that by the new evidence, which is the 0.71, and you're going to get about a 0.788 or a 79% probability. So let me know if you have any questions on that. Now, let's jump into example 2, or exercise 2. In this exercise, the goal is to discuss how Bayes' rule updating improves chatbot's accuracy, as we talked about throughout this entire lecture so far. As it processes more data, this concept is crucial because it showcases the chatbot's ability to learn and refine its understanding dynamically. So now think about the concept explanation here, right? So Bayes' rule updating allows chatbots to refine the prediction over time by consistently adjusting their belief based on new evidence. Initially, a chatbot starts with a prior probability based on historical data or general assumption, which may be around 0.5, which is half-half. As the chatbot interacts with more users and gain more information, it applies Bayes' rule to update their probability. So I think some things we want to think about is some key points to cover, right? And we want to understand that the initial guessing early on, chatbots estimate based on general assumption, right? Which could be a 0.5, as we discussed before. The bot might the bot might be uncertain about the user's intent and what it needs. So it predicts, so the predictions are less accurate. With each interaction, the chatbot gathers new evidence, which is more user input, feedback, and outcomes that applies the Bayes rule to recalculate the likelihood of each user intent. And then we get into some of the refining of the prediction, right? So the chatbot receives more information, which is more data. Its posterior probability becomes increasingly refined. This means that the chatbot becomes more confident in its prediction and can be able to match users' intent to the right responses. And then how does this help with the user's input itself, our user's experience? So over time, this leads to a better user experience because the chatbot is more accurate to understand and respond to a whole wide variety of user input, even when the intents are more ambiguous or phrases are unexpectedly phrased. And then we think of adaptation, right? So one of the key advances of Bayes' rule is updating the chatbot's knowledge to adapt to changing patterns of user behavior. So for instance, if a user is beginning to ask a new type of information, the chatbot will adjust its probability to recognize the new intent. Now, I know we're beating this like a dead horse, but I really want to kind of take this last point home. So let's talk about an example here. Let's say that a bot is designed to handle greeting and information-seeking intent with equal probability at the start. However, over time, users frequently ask questions about the weather or sports scores, showing a stronger preference for information-seeking queries versus greetings. Through Bayes' rule and it updates the bot, starting to adjust prior assumption. For future inputs, the bot will be assigned a higher prior probability to understand more of the information-seeking intent, meaning it will be better to predict users' input, and the users are more likely to ask questions rather than greeting the chatbot. So next, we'll get into the section 2. And in this section, we'll talk about the chatbot handler for your project. So these are some of the things that we'll talk about. We'll talk about the chatbot handler. We'll talk about some of the how to construct it more effectively and some examples of it and how to be more effective. So we're going to dive deep into the concept of chatbot handler. In essence, a chatbot handler is a centralized class for a system that manages how your chatbot processes users' information. This determines the appropriate response and maintains the flow of conversation. Think of it as this, as the brain that coordinates all of the moving parts for your chatbot. So we'll think about the chatbot handler. let's see what it takes care of. Some of the things that it takes care of is the user processing. So it helps understand what the user is saying. The intent recognition, it helps determine what the user wants based on the input. Response generation, response generating, figuring out how the chatbot should respond, and conversation flow management, which is essential to understanding that the chatbot maintains the context and moves forward with the conversation versus always having something new to talk about. So we'll break these concepts more and we'll explore different parts of the chatbot handler. So why use a chatbot handler to begin with, right? So using this chatbot handler is beneficial because it enforces the separation of concern. So instead of having all your chatbots logically scattered across the various methods or scripts, the handler centralizes everything, making it easier to understand, maintain, and expand over time. For instance, as you add more features to your chatbot as we go on through this course, since a new intent or response will happen, you don't need to rewrite the entire code. Instead, you might modify the chatbot to recognize new intent, generating appropriate responses. Moreover, this architecture makes the chatbot more scalable. If your project grows and you need to support multiple layers of queries, integration new features, or having into a more well-organized handler, this is pretty straightforward. Lastly, it ensures maintainability. So meaning that it will be easier to troubleshoot and improve your chatbot down the line versus having everything scattered all across the board. So now let's talk about the basic structure of the chatbot handler. This class is typically has a few core methods that handles different aspects of the chatbot, and we'll talk about it here. So the process input user, which is self and user input, this method is responsible for taking raw information. This method is responsible for taking raw user input and processing it, such as removing punctuation, converting it into lowercase, and tokenization, as we talked about before. Recognition intent. So after processing the input, the method analyzes it to determine that what the user's input is. It could use regular expression, keyword matching, or even machine learning models to do this. Generate response. Based on the recognized intent, the method can generate a response which could be predefined or dynamically generated. So predefined is how we're going to do the first project and having it more dynamically generated in the second project. And then we jump into manage flow. This is crucial for more complex chatbot. It tracks where you are in the conversation and ensures that the chatbot responds with context, rather than treating each new message as an individual query. We'll soon go through some code examples to help bring this to life. So as you see here, we have a chatbot class. Notice that it is the main component which we discussed earlier, which is the input processing, intent recognition, and response generation. So let's break it down again, right? The init method, we initialized a conversation context variable, which could be expanded to store things like user preferences or previous interactions. The process input method takes the raw information and does basic pre-processing here. It converts everything into lowercase and splits it into an individual word. And again, we have a recognize intent. We use simple keyword-based approach. So when we do this, if the process input contains a word, hello, the chatbot recognizes that this is a greeting intent. If the chatbot contains the word bye, it recognizes a farewell. If the input doesn't match to anything, it results into a unknown or a fallback response. The generate response method generates a response based on the recognized intent. If the intent is a greeting, again, the chatbot responds with hello, how can I assist you? And then finally, what we have here is the handle conversation, which ties everything all together, processing the intent, processing the input, and recognizing the intent, and generate a response. This basic structure is what you need to help expand your project and understand more complex situation and intent. So next, as your project grows, you'll likely need more support and then more information to seek just a simple intent to like a greeting and farewell. For example, you might need the chatbots to handle intent like information seeking, such as what is the weather, or a command, such as turn off the lights. To handle more complex situations and cases, you can extend the chatbot to handle support. You can have the chatbots to expand and handle more complex models, such as the supporting multiple intent, right? So to expand on the recognize intent method, it recognizes a wide range of intent within the NLP models or a decision tree. You can also add a context awareness. So instead of treating every input as a new message, the handler can help keep track of the current conversation, context. This way, chatbots can provide more information and be more relevant. And then what we'll do is incorporate more NLP models. So to improve the intent recognition, you can integrate more advanced NLP models, such as like those based on machine learning that we'll get to dive in more excitingly later. That can intend to help understand more complex sentences and user queries. So that's all that I have for this week. Next week, we'll jump into more exciting stuff and we'll talk more about some machine learning aspects and expand more on the project that we have at hand. So if you have any questions, feel free to reach out.